Sample space and probability. The theory of probability grew out of the study of various games of chance using coins, dice, and cards. We will explore basic concept of probability, then the type of probability and probability rule are discussed. The basic concept. A probability experiment is a chance process that leads to well-defined result called the outcome. An outcome is the result of a single trial of a probability experiment. Sample space is the set of all possible outcomes of a probability experiment. For example, first one, let's find a sample space of the following experiment. Well, you toss a coin, then you can either get head or tail. So this is the sample space. You roll 2 dice. Well, you roll 2 dice. The first dice you can get 1. Second one you can get 1. All possible outcome of rolling the dice. Then you can have 2 1, so on and so forth to sit 1. Keep going, right? And you can have sit. So this is the sample space. So in the first one, the sample space, the 2. In the second one, the 36 number of outcome. Find the sample space for the gender of children in a family have 3 children. Use boy for boy and G for girl. Okay, so if you have three kids, well, then we can have a boy, then a boy. We can have a boy, then girl. You can have boy, girl, boy, girl, boy, boy. We can have 2 girls, 1 boy. So we can have girl, boy, girl. We can have boy, girl, girl. Or we can have 3 girls. So then here we can see that these are 8 possible outcomes. The tree diagram is a device consist of line segments emanating from a starting point, also from the outcome point. It used to determine all possible outcomes for probability experiment. Use a tree diagram to find the sample space for the gender of 3 children in the family. So start here. Our first child can be a boy or a girl. The second child could be a boy or a girl. The third child can be a boy or a girl. Boy, girl. Same idea. So then we can read the outcome as follows. So we have boy, boy, boy. Then we can have boy, boy, then girl. The next one, we can have boy, girl, boy. Boy, girl, girl. Girl, boy, boy. And girl, girl, girl. Oh, we missed we miss a brand here. It's supposed to have a girl here and a boy here as well. So let's add that in. So then this is girl, boy, girl, and girl, girl, boy. So there's 8 possible outcomes there with a tree diagram. An outcome is the result of a single trial of a probability experiment. In many problems, one must find the probability of 2 or more outcomes. For this reason, it is necessary to distinguish between an outcome and an event. An event consists of a set of outcomes of a probability experiment. Simple event is the result of a single trial. For example, rolling a dice and get a 5, right? So 5 is an event, but the set of the outcome of rolling a dice, you can roll 1, 2, 3, 4, 5, 6. So that is the set of the outcome. Compound event consists of 2 or more outcomes or simple event. For example, rolling a dice and get an odd number. There are 3 basic interpretations of probability: classical probability, empirical or relative frequency probability, subjective probability. In classical probability, the classical probability uses sample space to determine the number of probability that an event will happen. Classical probability assumes that all outcomes in the sample space are equally likely to occur. So the probability of an event E is the number of outcome E divided by the total number of outcomes in the sample space, and is denoted by P of E equal N of E divided by N of S, where N of S is the number of outcomes in E, and N of S is the number of outcomes in the sample space. The Rowden rule. Probability should be expressed as the reduced fraction of round to 3 decimal places. When the probability of an event is extremely small decimal, we round to the decimal place to the first non-zero digit after the point. For example, a multiple choice test has 5 choices per question. If you guess the answer, what is the probability of getting the right answer on one of the questions? So in one question, we have 5 choices, and there's only one correct choice. So probability of correct choice is equal 1 divided by 5. So this is 0.2, or about 20%. Empirical probability. Given a frequency distribution, the probability of an event being in a given class is P of E equal frequency of the class divided by the total frequency in the distribution, or F divided by N. The empirical probability is based on observation. This approximate probability tends to get closer to the actual probability as the number of times the procedure is repeated increases. This is known as law of large number. Simulation are sometimes used when it is impractical or impossible to get a large enough number of total outcome. A simulation of a procedure is a procedure that behaves in the same way as the procedure itself, so similar results are produced. In a sample of 50 people, 21 have type O blood, 22 have type A blood, 5 have type B, and 2 have type AB. By the following probability, a person have type O blood. So the probability of type O, that is 21 out of 50. The person that have type A plus is 22 out of 50. Subjective probability use a probability value based on educated guess or estimate using knowledge of the relevant circumstance. This type of probability are based on opinion, inexact data, or educated guess and past experience. So, for example, what is the probability that it will snow in Livermore in the winter? So, Livermore is close to Tracy, in the Bay Area. So, the probability that it actually snow in Livermore is slim to none. So, very low. So, slim to none. Probability rule. For any event E, the probability of E is between 0 and 1, inclusive. The sum of the probability of all outcomes in the sample space is 1. The probability of an impossible event is 0. The probability of an event that is certain to occur is 1. For example, find the requested probability using classical approach. Write your answer as a simplified fraction and decimal that is rounded to 3 decimal places. The probability of rolling a 5 on a 6-sided dice. There's only one side of the die that have number 5 on it out of 6. Rolling 2 dice, find the probability of getting the sum of 7 or 11. So when you roll in 2 dice, and we want to get the sum of 7, let's say the first one you roll 1, the second one you have to roll 6. So how many times did this actually occur? 2, 5, 3, 4, 4, 3, 5, 2, 6, 1. So that is to get 7, right? But to get 6, we draw a 5 or a 6 or a 6 or then a 5. So there is 36 possible outcomes in this. So probability of rolling 7 or 11. How many times that would actually happen? So we have 1, 2, 3, 4, 5, 6, 7, 8. 8 out of 36 times. Simplify this by 4. So it's 2 out of 9. A family wants to have 3 children. What is the probability that exact 2 of the children are girls? Okay, so we know that we have 8 possible outcomes that we did earlier. So let's go back to that tree or that chart we did earlier. So probability of having 2 girls. So we have 1, 2, 3. Right? So the 3 actual chance that it would have occurred. So that would be 3 out of 8. In the next example, we want to find the requested probability using empirical approach. Write your answer as a simplified fraction and a decimal answer that is rounded to 3 decimal places. Any rural speed limit for all 50 states are indicated in this table. We have 60 miles per hour, 65 miles per hour, 70 miles per hour, and 75 miles per hour. If you choose a random state, what is the probability that is the speed limit 75 miles or less? So when do we have 70 miles per hour or less? Well, the 70 mile or less, then we have 60 mile, 65 mile, and 70 mile. So then the probability that we choose one at random, 70 mile per hour or less, actually equal, well, the total of the change that it would actually happen divided by the total number of states. And we get that 0.74. In the next case, given the following two-way table, answer the question below. In the surveys of 1,000 people, subjects are asked for their gender and if they smoke cigarette. The table below summarizes the result. Okay. So if one response is random select, find the probability that the subject is a non-smoker. So how many non-smokers that we have? The non-smoker in total is 205 out of 1,000 people. So probability of non-smoker is equal to 205 out of 1,000. If one response is random, so if one response is randomly select, find the probability that the subject is a male. Well, the male is in the first row. So 551 out of 1,000 people. Complement. To pick not something is called a complement. Sometimes it's easier to count on the one you don't want than subtract, right? Say for example, in this case, choose one at random. What is the probability that the speed is 70 miles per hour or less? Well, I can calculate this by taking 1 minus the probability of 70 or more than 70. And according to our table, more than 70, they're 13 out of 50 states. And that is the probability of the speed stay with speed limit that is less 70 miles per hour or less.